Hi, we're back. It's QBUS-110 4/3/20. It's Friday, and we're going to continue in our path through implicit differentiation. And we're going to take another example. We're going to find dy dx given x third y squared plus y fifth plus x fourth plus 2 equals 0. This is a non-separable equation. I cannot separate x and y on one side and the other side of the equation. I've taken the chain rule and I've altered it a little bit so we don't get mistaken. The derivative of a function with respect to x is the derivative of that function with respect to y. That's a function of y, dy dx. That's our chain rule. So let's look at our terms here. We want to find dy dx, so we're going to find d dx of x third y squared plus d dx of y to the fifth plus d dx of x to the fourth plus d dx of 2, and that's 0. Notice this is a product rule. So I'm going to call u x third and v y squared. So this is going to be x third times the derivative with respect to x of y squared plus y squared times the derivative with respect to x of x cubed. This one is simply the same thing, d dx y to the fifth. Okay, this is d dx x to the fourth. I'm going to just write that as 0, as the derivative of a constant is 0, and the whole thing equals 0. Now notice here we have x and x, so I can simply take it the way I normally do. The power rule times 3x squared. Here we have a y and an x. I cannot take a derivative of a function of y with respect to x, so I have to use the chain rule. So I'm going to take the derivative of the y with respect to y, and then I'm going to tack on the little chain. And this here, d dx, is going to be simply x and x. That's okay. 4x third equals 0. Let's go back to here. X third, x and y. I can't take that with respect to y. So, with respect to x, so I have to once again use the chain rule formula and tack on this appendage. All right, going through this, we get x third times 2y dy dx plus, just making this a little bit simpler, this is going to be 5y to the fourth dy dx plus 4x third equals 0. So now what I want to do is solve for dy dx. That's my variable. It says find dy dx. Here I'm finding it as a variable. So let me go up here. And I'm going to subtract all the terms not in dy dx. So I'm going to bring this, and I'm going to bring this over to the other side. That leaves me with 2yx to the third, just to rearrange it.
This should be x squared here, right?
I'm sorry?
Minus 3x squared, y squared.
3x squared, y squared. Thank you. Okay. It's tough when I get to the bottom of the board.
A lot of terms.
Yeah. So you get 2y, I just rearrange that, plus 5y fourth, dy dx equals, these are minuses 3x squared y squared, minus 4x to the third. Now since I want to solve for dy dx, I'm going to factor the dy dx out. So I get 2y x third plus 5y to the fourth equals minus 3x squared y squared minus 4x to the third. And I'm just going to divide this by both sides, which will give me my solution.
2yx to the third in the denominator.
These cancel. So dy dx equals minus 3 x squared y squared minus 4x cubed divided by 2y x cubed plus this is 5y to the fourth, correct?
Yep.
There's my answer. Notice my answer has both x and y's in it because this equation that we started with is actually a function of both x and y. It has both x and y in it. So this is your answer. Now if you knew a value for x and a value for y, you could solve this. And what we're going to do is we're going to go on to a problem in which we have to do that. And it's a problem which a lot of people don't like. It's a problem of finding, just make sure this is copacetic with what I got before. Notice what we did. Once again, let me reiterate. We never really took this differential dy dx. We set it up as a dummy variable, and we solved for it. They asked us to find dy dx. We found dy dx. Doesn't make any difference how we did it. We did it. That is the answer for dy dx. Now let's take a more practical problem, one in which we will substitute some numbers. And this is a problem that a lot of people don't like, these problems. But let's do example 4. Okay, let's find the line tangent to the following function. And this is going to give us some points at 2 and minus 8. That's going to be x and y. All right, so here's the function. Function is x third plus xy plus 4 equals 0. Now, in this case, I could separate this out and solve it in terms of y, but I'm not going to do that because I don't want to do a division. So this is a separable function, but even though it is a separable function, I can still solve it using implicit differentiation, and we'll get the same thing. So we want to find the slope. So the slope of this straight line is going to be dy dx, which is d dx x third plus d dx x times y plus d dx 4. How much time?
5 minutes.
Okay, Once again, this is okay. You got an x and an x. That's 3x squared. Now here we're going to have the product rule again. It's going to be x times the derivative of y plus y times the derivative of x. And the derivative of constant is 0. So this is a little bit easier than we had before. 3x squared remains the same. I cannot take the derivative of y with respect to x, so I have to use my chain rule. I just set up a d dy over the y, and I attach on the appendage, which is what I want to find. The derivative of that is 1. So now, but again here, 3x squared plus x dy dx plus y equals 0. Notice I only have one term in dy dx this time. So what I'm going to do is solve for it by bringing everything over to the right side except the x dy dx. Let me erase this part up here. This was the solution to the last one. So I'm going to get the x, dy dx, and I bring the others minus 3x squared minus y. You should be able to do that now. And I just have to divide by x. So dy dx is minus 3x squared minus y over x. This actually is my slope of the line I want. But in order to find the slope, the actual slope, the slope is a number. So I have to find dy dx. Notice I need both x and y here. What did they give us? They gave us 2 and minus 8. So we substitute in here minus 3, 2 squared, minus a minus 8 over 2. And you're going to get here is minus 2. So that is the slope of your straight line. In order to get the rest of the straight line, I just substitute in the y-intercept form the point slope form. So I'm going to go here. Y minus y 0 equals the slope mx minus x 0. We know the slope is minus 2. We know the first x is 2. And the first y is minus 8. So y plus 8. Distribute this. Minus 2x plus 4. Subtract 8. We're almost finished. And we get y equals minus 2x minus 4, which is our answer. That's the equation of the line tangent to the function at the point 2 and minus 8.